Alright, welcome. Today we are talking about angles of elevation. This is just another continuation of the work we were doing last time on trigonometry. Basically, if you understand how to set up the problems involving sine, cosine, and tangent, this is really the same thing. The only difference is that we're using word problems instead of pictures that were given to us. Of course, there's a little bit of vocabulary that we need to be familiar with. Those two terms are angle of elevation and angle of depression. So if you look at the diagram, we see the guy looking into the crowd. We see the angle of elevation marked here. An angle of elevation just means the angle that he has to look to see someone up at the top of the higher vantage point. The angle of depression, on the other hand, is the angle that the higher individual has to look down in order to make eye contact with the person at the lower vantage point. So when we sort of draw these out, the angle of elevation and angle of depression will both always be made with the horizontal side of whatever picture that we're drawing. But mathematically, it's going to end up being the same, because if we remember how parallel lines work, the angle of elevation and depression form a pair of alternate interior angles. And since our horizontal lines are parallel, those alternate interior angles will be congruent. So if you always place your elevation and depression angles on the horizontal side, it doesn't matter whether you end up drawing the triangle upside down or whether you're drawing it correctly. So if we look at this example here, we want to solve for the height, how far she needs to stand from the castle. We're given the height of the castle and the angle of elevation from her vantage point. So notice that 190 feet goes all the way to the ground. And if we are solving for x, we're going to need to sort of draw it out as if we are only looking at the right triangle. So we're going to need to separate the 5.5 feet of her height from the actual value of the triangle. So instead of 190, let's pretend that that says 184.5. Again, I just subtracted the 5.5 from the 90. So if we look at what we have and we look at what we're looking for, right? We go back to our sine, cosine, and tangent. So x is our adjacent leg. The 184.5 is our opposite leg, so we're using tangent. So we'll say the tangent of 38 degrees is equal to the opposite leg over the adjacent leg. And there is our proportion. So just like last time, we're going to cross multiply. And we're going to end up taking 184.5 divided by the tangent of 38. And if our calculator is in degree mode, we should get the right answer by simply typing this in. So we should get that x is approximately 236.1. Question said round to the nearest foot, so our correct answer is 236 feet. Alright, so for example 2. This time we are given an angle of depression, but if you look at the way the triangle shapes up, it actually winds up looking pretty much exactly the same. So again, we want to refer back to our sine, cosine, and tangent. So when we set it up, tangent of 42 degrees is equal to the opposite leg over the adjacent leg. Get our proportion and cross multiply. Since the x wound up on the bottom, we know we're going to end up taking 18 and dividing by tangent 42. And that's our answer. So x is about 19.99. It wants us to go to the nearest foot, so once again we'll round up and get 20 feet. So as we can see, what we're doing now is no different than what we did last time. It's just, again, word problems instead of just triangles that are given to us. All right, so for our final example, notice this time we have multiple triangles stuck together, right? So we've got this little blue triangle here. We've got the big red triangle here, and we've got two missing pieces. So this one is going to involve a little bit more algebra, but the setup is not terribly difficult. So what we're going to do is take the small triangle first, right? Again, referring back to SOHCAHTOA. You know that tangent of 70 degrees is equal to x over y. And then for the red triangle, the tangent of 26 degrees is equal to x over the entire bottom portion of the triangle, so that's 10 plus y. We're going to get our proportions. So when we cross multiply, we get that x equals y times the tangent of 70. And then over here, we get that x is 10 plus y, tangent of 26. Since both sides are equal to x, right, we know they're equal to each other. So y times the tangent of 70 equals 10 plus y tangent of 26. So now we solve it like an equation. If you are more comfortable working with this in decimals, you can definitely type out that tan 70 and that tan 26 to get a decimal. But we're going to work this out leaving the tangents the way they are until the very end so we get an exact answer. So right now what I'm doing is I'm just distributing the tangent 26. Remember that tangent 26 is just some sort of weird decimal. Right? It's just a number, so we're just going to treat it like a number. I know I want my y's on the same side, so I'm just going to subtract it over. So y tangent of 70 minus y times the tangent of 26 is equal to 10 times the tangent of 26. And so now since we are in geometry and not algebra 2, what I'll go ahead and do is subtract these two on my calculator. So I'm going to type tan 70 minus tan 26. Because we know if we have two numbers with the same variable, you just add or subtract them like normal and then stick the variable on the end. So if I do that, that's about 2.26. So we can say 2.26y equals tan tangent of 26. And so of course I can just divide that to the other, divide the 2.26 to the other side. So if I take 10 tan 26 divided by 2.26, get that y equals 2.16. So we go back and we say that the question wanted the height, which was x. So we go back to what we had before. X equals y times the tangent of 70. So that would be 2.16 times tangent 70. So if we just multiply that out, that's our answer. That is all I have for you guys today. I will see you next time.